Hello everyone, welcome back to Algebra 2 class. Today we are going to continue talking about logarithms, and our focus today is going to be the graph of logarithms. So we are going to use this example to create some graphs and do some, we are going to compare the graphs here, and also we are going to go back to review the domain and range to analyze both graphs. Okay, so let's get started. As you can see here, we are going to graph the two things, which is, let's focus on the part we are going to do. We are going to focus on the log 3x, and we are going to graph y equal to 3 to x power. And we both know that this is exponential. And this is, of course, we know that logarithmic. Also, some students might wonder why we call its inverse, and today we are going to use graph to demonstrate the relation between these two, and you will have even better understanding regarding why do we put these two functions in the same chapter. Okay, so when we graph, we all know that if we do not use graphing calculator, we are going to use a table, meaning we are going to give the value of x and get value of y, and we are going to get several pairs of the points, and we just need to plot the points. Let's do that. So for y equal to 3 to x power, again, the reason we call exponential function because the variable is in exponents. So that's why we call exponential function. Now we are going to use these values of x to demonstrate y. So 3 to negative 2 power, remember we just replace the x value here. 3 to the negative value is going to be 1 over 9. 3 to negative 1 power is going to be 1 over 3. 3 to 0 power, remember any non-zero number to the 0 power is going to be 1. And 3 to the first power is going to be 3. And 3 to the second power is going to be 9. So now we are going to plot these points in the graph, and let's see how does it look like. So for this kind of value, we know it's kind of very, very small, like close to 0. It's not really touching 0. So we are going to just estimate the position of this one. So when x equal to negative 2 is going to be 1 over 9, so it's like a very, very low position. And negative 1 is going to be 1 over 3, a little bit higher than that. And then 0 is 1, 1 is 1, 2, 3. As you can see, it's like a jumping, right? 2 is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why, when we give the demonstration of the exponential function, I mentioned, for example, when you look at the spreading of the virus, that's why from the first person to the many person can take such a short time because it's increasing exponentially. Now we are going to connect the points. Remember, when you connect the points, since we know it's going to be the curve, so you are going to connect it slowly and smoothly. So I'm going to just get the trend of this. You can stop a little bit and then just continue graph. It's gonna be forever, so if you do not think this very smooth, you can just trace a little bit. It's not perfect, but this is our y equal to 3x. Now what I'm going to do is whatever the x value here, whatever the value here, I'm going to use as x value. I'm use a different color so we can compare. And you will see what happened to this value. So I'm going to put this value here. You may wonder why, and soon you will see this. So this one is that's going to be log 3 1 over 9. So as we all know, 3 to what power is 1 over 9? Negative 2 power. Log 3 1 over 3. 3 to what power is 1 over 3? Negative 1. And log 3 0, or log 3 1. 3 to one number equal to 0 is 1 is 0, right? It's just a 3 to 0 is 1. Log 3, 3. 3 to a power is 3. 3 to the first power is 3. Log 3, 9. 3 to a power is 9, 2. So some students are notice, hey, you basically reverse the two value to this box, but this is actually match what we find when we put the value to find the y, right? So that's why this two is called inverse function. Remember, when we introduced inverse function in the first chapter, we mentioned the most important part is first there are one-to-one function, one x matching one y, and also the relation between these two is x1i will be reversed in its inverse function. Now, we are going to plot these points. Let's see what happened. So as you can see, when x equal to 1 over 9, it's like a close to 0, but it's not really 0. So we're going to just estimate. So 1 over 9 probably here is going to be negative 2. 1 over 3 is kind of here. It's going to be 1. And then 1 is 0. 1, 2, 3 is going to be 1. And then 9 is going to be 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be 2. Okay, now, again, I'm going to connect them, but very, very smoothly. Do not just, go very quick. Sometimes it's going to be mess up your graph. Okay, seems not bad, right? So it's kind of, just, keep going. Okay, so if you check the both graph, it's like this graph is flip. I'm going to draw a middle line here. Actually, this time I'm going to use this one. Okay. We are going to, I don't want to use this graph. Hold on. I don't want to use, let's use green. Okay. This is similar to, if you just really, really pay attention to the graph here, the blue one, which is y equal to 3x, is kind of flipped over through this green line to the red one. And this green line is actually y equal to x. And this graph is, as we mentioned, is log 3x. So that's why the relation between inverse functions is always a reflection over y equal to x. If you folded this picture through this line, you will see these two are a match. Okay, now let's just quickly analyze the domain range for each one. And you will have a better understanding. Again, the exponential function, I'm going to use blue. The log, I'm going to use red to tell the difference. So the domain is all about x. As you can see, for the x part, for the exponential, the blue part, x can be everywhere. So it's all real numbers. So x can take any number for the exponents. For the range, if you pay close attention, I don't see any graph under x-axis for the blue part. So that means y can only greater than 0. Now, let's focus on the red part. So red part is, again, x. If you check the graph, everything is on the right side. I don't see anything on the left side. So x greater than 0. And for the range, again, even it's slowly, it's very slowly increasing and it's very slowly, like a little bit sharp to down, but it still is going to be all real number. And again, some students are notice, you kind of just switch x and y. Yes, remember, they are inverse functions, so that's why the x and y switch. So that's why they look like this. Okay, so that's all I want to share with you. Another thing I want to tell you today is in the second video, I'm going to demonstrate how to use graphing calculator to graph it. And also I will give you some options to access the digital graphing calculator if you do not have, if you do not like a physical one at hand. Thank you so much for checking this video. See you soon, everyone.